Now today we're gonna find f parentheses 3c minus 4 parentheses 5f parentheses c if fx is equal to x squared plus 2x minus 3. Now for the first part, we're gonna find f3c minus 4. Now to do that, we'll plug in f3c minus 4 into fx equals x squared plus 2x minus 3, which we'll have right there. After that, all you do is multiply in the parentheses, which you'll get 9c squared minus 24c plus 16 plus 6 minus 8 minus 3. And you just simplify combine like terms and you get 9c squared minus 18c plus 5. Now we're gonna find 5f parentheses c. To do that, we'll just plug in 5fc into fx equals x squared plus 2x minus 3. And you'll get 5f parentheses c equals 5 parentheses c2 plus c plus 2c minus 3 parentheses. And if you distribute 5 into the parentheses, you'll get 5c squared plus 10c minus 15. Now, after we find both answers to f3c minus 4 and 5fc, you'll get the answers for both of them and subtract the answers. So it'll look like f3c minus 4 minus 5fc, which is equal to parentheses 9c squared minus 18c plus 5 minus parentheses 5c squared plus 10c minus 15. Now after you do that, you subtract and combine like terms, which you'll get 4c squared minus 28c plus 20. Now, how do we determine if the function is odd?
Introduction to concept. First, let's start with odd degree functions. Odd degree functions will always have an odd number of real zeros. Now, let's ask the question of what is a degree? The degree and leading coefficient of a polynomial function determines the end behavior of the graph and the range of the function. And as we look to the example on our right, where it says f parentheses x parentheses equals x5 minus 5x4 plus 5x3 plus 5x2 minus 6x. And we look at this, we can see that there are 5 degrees, which means there are 5 x-intercepts. And in general, an odd degree polynomial function of a degree may have up to as many x-intercepts as it needs or wants. Now, let's look over here. What is the difference between odd functions and even functions? To determine if it's an even function, graph it out on your graphing calculator, and to see if it's even, the left half of the graph exactly reflects the line or shape on the right half of the graph. For odd functions, the left half of the graph exactly reflects the line or shape on the right half of the graph, except it's upside down. So if we look over here, we can see it says odd functions, and we can see the graph of even functions. Odd functions, like I said, you would have the reflection of the left half of the graph exactly reflects the line or shape on the right half of the graph, except it is upside down. And for even functions, we can see that the left half of the graph exactly reflects the line or shape on the right half of the graph. And that is how to determine the difference between even functions and odd functions.
For the Regent examples, me and my group, we chose two Regent questions, and the first one is number 4, and it says which equation represents an odd function. So the first thing that we want to know is what makes an odd function an odd function. So as my past group members explained, an odd function is when the graph is unchanged when rotated 180 degrees about the origin. So we want to graph all of these on our calculator, and we are going to see which one is unchanged 180 degrees about the origin. Okay, so now that we have graphed all of them, the only one that is not changed when rotated 180 degrees about the origin is number 1. Okay, so the second one that we found is number 6, and it says algebraically determine whether the function is odd, even, or neither. So the first thing that we want to do is rewrite the equation and as negative x. So we're going to do j equals negative x over 4. We have to do this in parentheses. Minus 3 negative x parentheses 2 minus 4. So this equals x4 minus 3x over 2 minus 4. So since j parentheses x is equal to j negative x, jx is even.